Hello, everyone. I'm Kristina Koleva, and today, Tuesday, November 15th, we're going to talk about some basic software testing stuff. My voice is not in its best shape, so excuse me for this. I'll be coughing here and there. Don't pay attention. I wondered what are the absolute key fundamental key points about software testing that I would like to share with various public, with developers, product managers, testers, or testers to be. You might find that these key points are a little diverse, but bear with me. I think you'll make sense of it, all of them at the end, and I'll try to walk you through the presentation relatively quick, so we have time for questions. Anything that challenges you right now about software testing, that bothers you, that you have any struggle with, if you're willing to, I'll be happy, more than happy to try to answer or guide you to some direction where you can find your answers. About me, my name is Kristina Koleva. I'm from Bulgaria. I've been testing for 16 years, various projects, more complex, some of them more complex, some of them trivial softwares. I believe that testing is not enough to really take good care of the quality of the product. You need rather, as I call it, a full picture process approach and consider quality responsibility, a whole team responsibility. And by team, I mean everyone in the company, not only in the developer team, in the development team. I want to help young teams to and spare some of the lessons that I've learned the hard way for them. Help them find their way to software testing and quality. Testing is very context dependent. Quality is very context dependent. It really depends on the team, on the business, the domain, and the customers, how to, what quality strategy we should choose. And some of you heard probably in the beginning, I'm not sure. I'm very solid rock fan. So this is what helps me make it through the day. I've asked you here, if you haven't yet, scan the code or open the chat. The link is in the chat. Who are you? And I see that we have testers and product managers or BAs. Awesome. I think you'll like the talk. It's a lot about you and how you can really feel more confident about testing. All right. So something funny to warm up a little bit. What is not software testing? And you've probably seen all of these. I've just Googled the software testing memes and GIFs. All this apparently is well done unit testing, but not very much integration. This one is more complicated. I'm very impressed. You can actually make it through the doors somehow if you're very fast, really fast, and the job will be done, but the user experience might be dangerous. And this is my favorite. It's brilliant, and I'm sure some of you have done home renovations, might have similar experiences. What's the point of these GIFs? They're context dependent, indeed, and every software needs to be carefully examined, its purpose, its mission, what the company wants to achieve with this software, why customers are choosing this product, why they are using it in order to really be adequate in the test strategy. But still, these are my three most powerful testing tools. Asking these three questions. What is the thing that must always work? You can't really unwind the tap and the water just flows on the floor. It's not relevant. And you might see this as some ridiculousness, but believe me, there are softwares that kind of do the same thing. The next, even more powerful question, and this is really within the scope of the testers and the quality engineers, is asking what could go wrong. Software engineers and developers are brave people. They don't want to be to be stopped or kind of pulled back when they want to create, to develop, innovate various softwares, complex algorithms, to find the programming solution, the architectural solution, the technical solution. They don't think about what could go wrong. It's a bias, and of course I'm kind of being very exaggerating a little bit to make my point, but what could go wrong is in the hands of software testers. Asking what could go wrong from day one is the most powerful tool you have in your hands. And it really changes the way we create requirements, we define the requirements, we identify the best technical solutions, we identify the test strategies, what is the risk, what are the things that we need to take care first if we don't want to have troubles in production later. And you see in one of the testing principles that troubles in production later are the most expensive things to fix. So keep asking what could go wrong. And the third testing tool is to put ourselves in the user's shoes, in the customer's shoes, and imagine what if. Imagine where the user is, what they're doing right now with our system, and don't assume they know what to do with our system and with the feature we have delivered to them. Don't assume they are aware or they're tech savvy like us or they're very strong with computers. Don't assume this. They don't know. And there are many software, mass production, e-commerce, all of the software that we as customers, we as users use every day. We don't know all of them. We know parts of them, the main flow that we're using, and even imagine one of my favorite examples are the shopping online. All of us here shopping online every day, and probably we do it differently. Each one of us probably search differently. We use different filters. We use the filters differently. We proceed to check out differently. We use different credit cards. We do it differently. We live different lives we have different backgrounds, different internet speed. We are in different places in the world, speaking different languages. Test for imagine how our real users are going to use our software, and what if they do this or that. This is the third most powerful testing tool. Keep asking these three questions since day one, since the moment you as a product manager have come up with an idea or you've been given a requirement. Keep asking these three questions all the time. They determine your testing strategy. They also guide the development efforts in an actual risk-based and context-based manner, and that will save a lot of troubles. Now, they're famous. These three things are backed up by testing theory a little bit and experience, of course. There are 7 famous testing principles. I will not show you all of them. You can find it. I'll share you the ones that I care the most. Top of it, I would call what is testing is being conscious about doing the right thing all the time. What is the right thing to do and how to do it the right way. You can also see this as if you search what's the difference between verification and validation. But in one sentence, testing is about being conscious. Is this thing working as it is supposed to? Is this thing, are we writing the code the way we would be proud with it, not in a quick and dirty manner? Have we described this user story properly? Are our test cases meaningful, thorough, achieving maximum coverage with minimum effort? This is what we're going to talk next, how to do that. But on top of that, testing is being conscious about the quality of our product, of our work life, and the way our users are going to feel when they use our features. So what are the most important testing principles for me? Especially for new colleagues, for junior testers, these 2, they are numbered in a funny way because I told you there are 7 of them, and you find them in a specific order. It's just two on their way. Yeah, the third and the second one, especially for junior testers that wonder, but how I'm going to test all of this? Well, don't worry. Exhaustive testing is not possible. What does it mean? It means that we cannot test any software, any piece of software in under all possible conditions, in all various production environments it can be used. And the most graphic example about this are the mobile applications. You have probably seen the so-called testing farms. These are cupboards, racks with hundreds of different devices. Some companies can afford this, most doesn't, most can't. So exhaustive testing is not possible. You cannot test all phones in the world, all tablets, with all the various operating systems and their versions. And then even if you can, this one phone, it's not isolated, it's not empty. It has photos on it. It has different other applications. It's not possible to come up with all possible configurations for a mobile app. So having this in mind, then what? Well, then we come up with a risk-based technique and asking these 3 questions. What is the thing that should and must and has to always work? What are the configurations that we must provide? What is the environment on the phone that kind of, for example, when you have a new phone, it comes with some pre-installed apps. We can assume or we can model what are the first or the typical applications that every customer out there between 30 and 40 years have on their phone. And then we come up with strategy. What configurations and what conditions to test. At the same time, even though exhaustive testing is not possible and we should come up with smart ways to decide what test cases or test conditions we need to test, don't be fooled the moment when you can't see any more problems or errors that they're not there. Absence of errors is a fallacy, meaning that there are always bugs. We just can't test all of them, and probably we won't find all of them. What's important, though, is to be creative. And this, if the first principle is telling us to be smart about the test cases and coming up with the highest risk ones, with the ones that will, if they fail, they will result in huge problems for the software, the company, the user. Then the second principle tells us to be creative, to come up with new ways to test. When we're done testing, come up with more. Test again. There's no, previously in the old days, a while ago, there was people on interviews that would ask question, when do you stop testing? You never stop testing. You might pause it for a while, but software is a live organism. It changes every day. There's no such thing like stop testing this or that feature. On the contrary, you might stop actively executing tests against it if you don't have automation, for example, but you might have monitoring tools and probing tools and looking into the production environment, observing how the feature behaves and collecting information about statistics about failures or exceptions. There are plenty of ways to test without actually executing test cases. But of course, you need to continuously test. There's no such thing like we stop testing now because we will never find all the bugs anyway, and we might miss some important ones. The most important principle, it's all about it. If you want to be successful in testing, if you want to really be proud of your testing work and have high confidence in the quality of your feature, is early testing. What does this mean? Early testing means that you as testers, or that testers, QA people, QA team, join the conversation about a new feature as soon as this conversation starts. A typical wrong, actually, way of establishing a test process is to give the feature to the testers when the coding is done. This is not just old school, it's detrimental, it's dangerous, it's high risk, it is slow, it is just wrong. Testing and thinking about testing, asking these three questions. What must always work? What can go wrong? What if I do this or that instead? Or what if the system doesn't respond, the system will integrate to it? Or what if we don't have enough bandwidth? What if this or what if that? Asking these three questions should start the moment you are introduced to the requirements, to the idea, to the plans about this feature before any requirement is written. And you should start asking, and you should hear about it as soon as it appears. The entire process of defining requirements should start with a tester in it. Early testing, or you will also hear it as shift left testing, is about identifying potential risks early in the development process, because the later a defect is discovered, the more expensive it is to fix, and the fix cost is grows exponentially. If I end out, you'll see a little bit in a while. that some test cases needs to be requirements actually. It's too late to wait for someone to write the test case, to read the requirement, to identify the test conditions, to write the test cases, to prepare the test data, to execute it, and to catch the bug. And that bug should have been written as a requirement 2 months before that. These are especially bugs that are the typical bugs like this are validations. And for those of you who actually work as testers, you know what validations are. Validations are all simple logic, like, for example, if you have a text box, what is the length of the string it's allowed to accept? Or what is the type? Do we allow numbers or alphanumeric, or only letters, or special characters, and what's the length? This is something that nobody does nowadays. Nobody care about validation. Nobody care about text boxes. What a tester would immediately do is to test this. Well, it should actually be a requirement. If you're implementing a feature and it has a text box in it, then it should be a requirement. Within the requirement, there should be a definition about the validational logic. Also, another, one of my favorite bugs, and this is what I always do when I test tables. Any table I have tested in my life missed sorting of the columns, or only some of the columns have sorting, some columns don't have sorting, which for me, it's immediate bug. It should be a requirement. Why wait for the customers to find it, if not me, if not us as testers? Instead, you have a table, make it a requirement. If you have table, then all tables, all columns of the table should be sortable, unless this or that condition. There could be, I don't know, pictures in there or icons. Then you cannot sort, of course. But if it's text, you can sort alphabetically, or in ascending or descending order if it's numeric, etc., etc. It's logical. It's common sense. Yeah, something that I should have asked, that I should have added to the presentation. Testing is about being conscious, doing the right thing, and if you're not sure sometimes whether something is a bug or it's not a bug really, follow the common sense. If there's nobody to ask, there's usually someone to ask, but it's all about common sense in the presentation of the software, in the behavior of the software, in the logic, etc., etc. So make sure to get hold of the requirements very early, even pair with the BA and with the product manager to write the requirements together, because this would also save a lot of troubles and misunderstandings and time. Let me just take a look. All right. Something a little bit it's very, I would say it's technical, but it doesn't matter. We're all technical. The fact clustering is a principle that I like a lot, because it's a problem with all softwares I have tested. The fact clustering says that 80%, it's a Pareto principle, 80% of the bugs are clustered in 20% of the features. And usually these are part of the system. Someone could call them legacy code. It doesn't mean that it is old code or outdated technology or anything. It means, sorry, it means that it's complex and complicated piece of the code, part of the system that is very fragile. It's part of the system that is very fragile, and it breaks often and random. It's a risk in the system, and we should always be taken care of. We should always have this piece of the software, this component in mind. We don't have. Let me just maybe can I ask? May I ask Steph to mute herself? Thank you. It's part of the system that we either are not ready to refactor, meaning to up a little bit, to make it more testable, make it less risky, less fragile, or it could be that someone has written it a long time ago and there's nobody to to really take it and make better use of it. The thing is that every software very often has, especially even if it's startup or not, it doesn't really matter. But I've seen this with startups that because they're very much in a hurry, they take some quick decisions here and there, and there is part of the software. It's usually very fundamental for the software that nobody dares to touch it, but it has a lot of problems. So with every new user story, of course, if you work in a project or a product for a while, you would know which is this part of the system that is kind of fragile and risky. But with every new user story, always have in mind that even it might look that it has nothing to do with that particular piece of the software, there might be problems there. So the defect clustering principle is a risk, again, a risk management principle. It tells us to watch out for this part of the system that usually has a lot of trouble. All right, a little bit. Yes, 2 more, and then we'll take a small break for questions. When you define test cases, when you execute testing, especially if you're doing the exploratory testing, and for those of you who are not sure yet, exploratory testing is nothing but playing with the system without previously having prepared your test cases or the routes that you're going to explore. It's all of us does it every day, and this is the first thing you would naturally do when you see a new piece of the software, new feature. You will just take a look and click around and see how it behaves and kind of get feeling about it. Then when you do this, note down all of your steps. Try to remember what you do. Take recordings. Best advice ever, take recordings of anytime you start a new test, take recording. If you find something, great. If something breaks, amazing. If it doesn't and it's kind of okay, do it a couple of times and then delete the recordings. You don't need them, or you might keep them for archive. But when you find something, and especially when you troubleshoot, don't try to test everything at once. Don't try all your ideas. Oh, but this could have costed, this could have costed, this could have costed. Don't try all of this at once, because you would never know what actually cost it. Usually there's only one condition that makes the difference between pass and fail. And this principle is very, again, very useful, very powerful for troubleshooting and for integration strategies. For troubleshooting, as I said, if something breaks and you find and you try to repeat what you did, you repeat it, the exact same steps. It seems so. Sometimes you cannot be really sure, but usually we can. It breaks again, fine. Then you make one change. it breaks again. Apparently, that's not the root cause. Then you make another change. It doesn't break. That's not the root cause. Then suddenly you make another change and it breaks, or it doesn't break, depending what you're trying to prove. One change makes the difference. Make sure that you identify the root cause of bugs and problems to one discrete reason. This helps fixing the problem so much. We've all seen bug reports from customers or from other team members that are not actively involved with the development. Bug reports that says that I did nothing and it broke, or it doesn't work. We've all seen this. Well, we as testers cannot afford to write a bug report saying it doesn't work. We need to be very conscious about what we have changed from one test to another that caused the thing to break. Again, to come up with the best cases, we use techniques and risk assessments. Why this principle is very useful for integration testing. I've seen, not many, but I keep talking to teams that don't have any automation. And they believe that the so-called, what they call end-to-end automation would cover the most. The thing about what they mean in end-to-end is really from user registration, for example, to confirming the delivery of a product through purchase, through selection, through purchase, through checkout, to confirming the delivery of a product, if we take that example. These end-to-end tests, they usually, and what is worse, that they usually start with UI automation, which is the slowest and the most expensive ones. This end-to-end test is will not benefit from it. On the contrary, they will start with this very huge initiative. They will it will take a lot of time. The test will be flaky, meaning unstable and kind of not reliable. And they will give up on automation because of this end-to-end approach. If they knew that principle, or they knew, of course, everybody kind of might make sense of it once they hear it. It's not, it's part of the so-called all pairs test design technique. You can search for it. If you identify how components in this end-to-end flow talk to each other, if you change one component, if you test only two components, and you change the next one, then you should be able to identify the issues much earlier. And these are smaller tests. These are tests that don't necessarily need to be UI. They could be any other lower levels of testing of the infrastructure in architecture that are much faster. Then you will find the bugs much earlier, and the dependencies between the components much easier, and they will be even faster to write. So that's why having in mind that one condition makes the difference between pass and fail, it's very useful for troubleshooting, and it's very useful when you think about integration and automation test strategies. And last from this part, again, to repeat, remember, we are customers ourselves. We should put ourselves in our customers' shoes. How, if we release this feature tomorrow, who is our customer? Who is our user? How they are going to use this? They will sit in front of their laptops or computers or phones. They will open a link, or what they're going to open, how they're going to do it, where they're going to click first, what they're going to do, why they're using the software, who are they, and etc., etc. On my YouTube channel, Software Stories, you will find some of the previous talks where we talked about how our user is going to feel about our feature is one of the other very powerful testing questions. All right. Before we move to test design techniques, time for questions. About the testing principles. I should have probably a summary. Test early, be creative, don't feel secure that if there are no more, if you can't find more bugs, there are no more any. Test early. What could go wrong? What's the thing that must always work? And what if I don't do the thing that's expected from me as a user? What else? What are the things that drive you in your testing and product management days?
It's mostly what the client expects from us, not the users, but the client. Because sometimes clients don't really think about their users.
Help them. Ask them. The clients also should, well, they're supposed to be constructing this software for their users, right? If their users don't like it, the client will suffer. Give me an example.
Well, in a meeting, our team is quite sure that the way the client wants the feature to work, it's not user friendly, but he insists because he likes it this way. So
do they have any arguments, or just I like it this way?
I like it this way is the argument.
Yeah.
And they usually say, if somebody complains, we can think about it
later. Yeah.
Yeah. And yeah, it's difficult because sometimes the common sense tells you that this is not fine, but on the other side, you have the requirements from the client, so you need to follow them.
Yeah. I totally feel you. Yeah, sometimes we have to do that. This is business. This is a software business. Educate them. We can always try. Of course, they're not obliged to listen, and most of the time they won't. Ask them sometimes, or I don't know. I would really get. I'm a troublemaker myself, so I would really get creative about if the entire team really thinks, and if we know the domain pretty much as good as the client, we could really suggest some early beta testing or usability tests. That's why UX and usability is gaining so much traction right now, because the user matters. It's the user. If the user doesn't like it, they will not use it. And yes, you can change it later, fine. If you're okay with paying twice for that feature and losing actually users, and you're paying clients because you said so. Yeah, sometimes we cannot do much about it, but we can play a little. We can try to suggest usability tests. You can ask them, have you talked to one of your users recently? You can encourage them to ask if they have customer support or if they collect customer feedback. Really working around that I said so attitude, which is inevitable here and there, but sometimes there are ways to try. You can always try, keep trying.
Yeah.
Usability, suggest getting a customer or make a usability test yourself and show them. It's nothing complicated. Just grab your friends or someone else from another team and record the screen while they're using it, record their reactions. It could be just the team next door that have not worked on this. No, just from top of my head.
Yeah, that's a good idea.
Yeah, because if the team really feels it's not common sense, come on, then we should fight for it. I would fight for it, of course, in a very smart way.
Yeah.
Sometimes we might not be, we might miss background that the client has and he's not sharing it with us. That's also an option that we really are not sure. And it could be a common sense for him indeed, but he would not share, or he doesn't think it's necessary to share it. So yeah, there are plenty of reasons for this. Most of them are not reasonable.
Yeah.
And are very subjective indeed, but I believe there are ways. And until we have exhausted all possibilities, it might be good for them to see, to learn something new, even though they are not willing to. I don't know, that's what I would do. Thank you for sharing this, Irina. Thanks a lot. All right, how test design techniques? Please Google it. These are the things that really made me a tester years ago. I've learned about them during ISTQB course. Some of you might heard it. ISTQB is the organization that put all the testing theory together years ago. They are kind of controversial, and you would hear polar opinions about them. Some hate them, some love them. For me, they were useful. Over the years, I've have my opinions towards some of their practices and policies. They have grown a certification business. Everybody does that. But the thing is that many years ago, when I first when I was starting to become a tester, and I first read the theory they have put together, it all come to its place. After I had been testing for 1 or 2 years, and the company I worked for organized that course 1 week, and it really, everything came to its place. I made sense of the work I've been doing, and it really helped me. And then I heard about the test design techniques, and test design techniques are there. It's a it's a family. There are several families: white box, black box, experience-based. You can Google it, go to the ISTQB site and find more about it. What I've chosen are the 3 things that I have been using every day, for 16 years. These test design techniques are a way to structure your ideas, what should be tested, to help you come up with test cases very mechanically. You need to think a little, of course. You need to identify the right test conditions, the right things to test, but the actual test data and test cases come very smoothly out of the test design techniques. So, and because I told you that some test cases need to be actually requirements, I have used this this title here: specify the output. You would hear it if it was in testing terms. I would say identify the input test cases. But here I want to say that these particular test cases that you would see should be part of the acceptance criteria, should be part of the acceptance test cases, should be part of the definition of ready. For a user story should be part of the requirements. I'm just mentioning here different ways to specify requirements. It should be part of the specification. You don't need to wait up until the code is pushed to the testing environment. Come up with this or write them down during the specification. Equivalence partitioning and boundary value analysis are the two techniques, most powerful ones, that deal with input, especially with numerical input, but not only. Once you get fluent in using it, you'll see that it can be used for anything, but it's very useful when you have numeric data. And what it does, if you have numeric input, it says that given a logic, you don't need to test all numbers for condition, for a logical path. You pick one of each logical path or one of each interval, partition, and all of the rest within that interval will behave the same. And I'll show you the example to make more sense of it. That's why it's called equivalence partition, because the numbers within with the entire interval behave the same, equivalently. They immediately work together. You would barely see a test case with only one or the other. It works together with the so-called boundary value analysis, and the boundary value analysis says that in addition to one number from the equivalence partition, you should also test the boundary of the partition, the boundary of the interval, not only the boundary itself, but depending on the specification, you test right below and right above the boundary too. So if you have, and let's see the example. A very simple example. We're booking a hotel. The hotel has discounts for children. If the kid is younger than 6 years old, free of charge. 6 to 10, 50%, 10 to 12 years old, 25%, older than 12, full price. If you only see the text, the common sense will make you ask, what about the boundaries? That's why they really work together. These are the equivalence classes. Whatever years you put below 6, it should be free of charge. You don't need to test 0, 1 month, 1 week old, 2 months old, 2 years old, 2 years and 3 days old, 2 years, 3 weeks and 5 days old. You know where I'm going with this. You don't need to test all possible numbers and years up until 6 years old. You need to pick one. Below 6, that's it. And because 0 is usually something that breaks, what could go wrong? Well, if you enter 0, it could usually break. We just pick a 0, but anything below 1 and 6, whatever you put there, of course, you specify if it's decimal, you specify if it's a decimal number or integer number, or whole number, and that's it. You test with 5, and you don't need to test with more. This is how test design techniques achieve maximum coverage for the equivalence partition under 6 or equivalence class under 6 years old, only by testing one number, one test case. On the right side, you will see how the boundary value, if it's integer, would be, for example, 5, 6, and 7. That's the boundary. 5 is also included in the equivalence partitioning, so we don't need more. And then an example if it's a decimal number, because I've seen, and some of you might have seen, that especially for kids, it's shown as a decimal with 5.99, for example. So these are all the test cases you need to test discounts. And I've chosen this example on purpose because it's the discounts are everywhere. We have discounts for amount, we have discounts because Black Friday is coming. We have various conditions under which we have discounts. Here is these discounts could be valid for insurance company, for example, and so forth and so forth. It's a typical software. Everybody works with this type of features in one way or another. So that's how powerful this is. This is how you come up with test cases. Questions. We have 2 minutes until 8. I have a little bit more to share, but probably we'll end up with, yeah, I have 25, I have 5 more slides. And a little bit more, but if you have time, just stay around. I also have time and we'll keep talking. Questions about equivalence partitioning. Have you used it consciously? Give it a try tomorrow. You'll see how powerful it is. It's very useful. All right. The second very, very useful technique, draw the flow. Either the so-called control flow, who is doing something with the object in place. Is it a user that is registered? Is it the order? What is it? What are you testing? You're testing something and it has a flow. Or is it the data? We collect data from somewhere. We transform it. We first store it, then we transform it, then we present it. Draw the flow. This is very useful, especially if you're a developer, before you start writing the code. But whatever, even if you're a product manager or tester or developer or UX designer, draw the flow. Imagine how the user will use, and then go one level below a little. Imagine how the program will work. What would the program do? Then imagine how the data will flow from here to there, how it will be transformed, depending what you're building. Draw it very simply, like this, with boxes and with circles and with arrows. This is an example of ATM, very mainstream, main flow. Why it's very powerful? Because once you draw it, you start thinking about the flows, the branches, the branched logic. What if this? What if that? What if the next? You imagine, you visualize it, and it's powerful to show it to your teammates. Even if you're a tester and you want to start writing the test cases, start with the flow first. Read about state transition diagrams. This is actually the name of the test design technique, state transition diagrams, but I wanted to simplify it. Draw the flow. And each test case is basically going from one circle, one bubble to the other, or one arrow. That's your test case. This, once you've drawn the flow and you've identified all, note here, it could be a big one. It could become very complex one. use the equivalence partitioning and cut it in pieces. You don't need to draw the entire system. Make it test case by test case, behavior by behavior. What's important? Risk management again. What could go wrong? What must always work? Then specify the behavior. And this is the test design technique that I really use every day. This is how I test everything. This is how I start to think. This is how I think testing already. It's called decision tables, but it's basically a logical table. Decision table, by definition, record complex business rules. Each row corresponds to a decision rule that defines unique combination of conditions, the columns which result in an execution of some actions. So in simple words, it's a logical condition table. If each column is a condition, if that condition is satisfied, but this is not, but the other is, and so forth, then this should happen. If condition A is true, condition B is true, expected result A. If condition A is true, condition B is false, expected result false. If condition A is false, condition B is false, expected result depending on the expected result. Everything can be depicted, every logic, every software, every behavior can be described in a decision table or in a logical table, condition by condition. This is what software does. It gets some input data, and based on this input data, which is the condition, manipulates, creates an object, manipulates it, and passes it through to the next method. This is programming. Taking decisions based on conditions. And this is the behavior of the system too. Our ATM example here, and you might notice that these are the optimized test cases. The yellow ones are the ones that matter. You need to have balance, and your balance should be within your daily, the requested amount should be within your balance, and the requested amount should be within your daily limit, and your PIN must be correct. So all these three must be in place. All these three conditions must be satisfied if we want a success message, get our cash and collect our card. All these three conditions must be satisfied. If some of them are not satisfied, it doesn't matter. The others doesn't matter. You don't need to describe them. You only need to make sure to test that within the balance is no, and then you should get an error message. This is a test case design optimization technique, but I would, especially if it's a new functionality, I will write all of the test cases. I will fill the entire table if I can, if it's reasonable, feasible. No, there are no 256 columns in it. I will run through them and scratch the non-possibilities, those that cannot happen, even though they just logically are presented in the in the table, they cannot happen because of other conditions. And then I will decide whether to optimize it at this level. This is kind of very optimized test case, or I will be more detailed and I actually add test for the other rows. Everything can be tested, can be described, and it's very useful to specify the behavior. It's very useful to ask what could go wrong question. It's very useful to make sure to communicate the testing intentions, the quality risks, the expected results with engineers and with product managers. And if product managers were writing requirements like this, all of our life would be easier. Because this is actually a requirement. Simple as that. So I encourage you to try decision tables as well and start testing your start writing your test cases first in a decision table, because it really helps you immediately spot what is non-possibility and what is what conditions don't really matter. So you come up with the ones that really matter, that make the difference, and that cover most or maximum, the maximum cover, that achieve the maximum coverage. Okay, questions about the decision tables? Evelina sent us something. Thank you, Evelina. Send us one of the favorite testing jokes. Do you see it? Thank you. Yes, absolutely. All the test design techniques with one, but yes, this is what we should we do every day. We do it. It's a joke because it's true. You know, it's funny because it's true, and we should keep doing it. And it's called equivalence partition and boundary value analysis.
Actually, I think that the first three questions that you mentioned in the beginning are very useful to prevent this to happen.
What could go wrong, right?
Yeah.
Oh, thank you so much. It was a good one. Okay. I have a couple of more slides, but I think I'll send you the presentation anyway in a follow-up email. I think I shared most of it. Yeah. Something about really about as a summary. Keep asking, be creative in the way you ask. Make sure, ask and demand to be at the table when the conversation about the user story or the new feature starts. If you're given a written requirement already, this is too late. Try to get involved, because everyone at the team, the developers, the designers, the DevOps team, the testers, we have so much input that if we provide it to the product managers before or while they're writing the story, we would save so much time in clarification later, or so much misunderstanding. So demand, ask to be very early, to start testing and test analysis and thinking about what can go wrong very early in the process. Use the test design techniques to really maximize the testing, to make sure you're testing discrete test cases, so you're not mixing or you're not writing redundant test cases. Pair with developers if you have a testing idea. Again, early in the process, tell them before they start writing. Pair with them, sit with them, encourage them to ask you how you're going to test it before they start writing the code, because it will also educate them. And example, if the validation is it's if you test validation every time and you keep, and they know the testers will test for long strings or for type. This should be educational, you know. Every new feature you test once, you report a bug about validation. The next feature again, you report a bug about validation. The third time again, you report a bug about validation. Well, at certain moments, I would expect that common sense will help, will guide developers to start asking at the refinement session, then to start asking about validation expectations before they start writing the code. It's kind of, it's a little bit of training, but this is what we should be doing. That's why if we are right there at the beginning, testing early and asking these questions early and sharing our test knowledge and test ideas and the test cases that we have written with the test design techniques early in the process, these test cases will, in 6 months, in 1 year, will turn into requirements. The test cases will improve the quality of the requirements so that we will not have to spend time writing a test case about validation, testing it, reporting the bug, planning, prioritizing the bug, developers are going to fix it, we retest it. All of this will be gone. We will spare this time for actual engineering, for dealing with the complex issues, for innovating, not with testing validation. It shouldn't be a requirement. But testers really can help with this growth, with quality, with good quality test cases. Participate in code reviews is something that I also encourage testers. Whether you're junior or not, don't be afraid of the code. Read it, look into it. Look, especially if your team is using so-called pull requests and they're doing code reviews, when it's very useful when the change is in a code review state, to look into the changed parts, the differences. What the developer has written, has changed in the code in order to implement this task. This is very helpful. You will get used, if you're not used so far to look into the code, you will start getting used to, you will start making sense about how a feature is implemented, and look into the comments from the other developers, because this will help you figure out what is good quality code. And something, when you start testing, when you start in a new company, for example, or even today while you're working, if there is no architectural diagram and no overview, no picture, actual picture of how the different components of the system work, what is the flow between them, draw it. Start drawing it yourself. You will learn so much. And if it's not there, it means that there are a lot of defects clustered somewhere, because nobody knows actually. So, and if the architectural diagrams are very, very useful to determine the test strategy, to determine and to identify very risky and shady parts of the code that usually break. It's very useful. So if there isn't any, draw it. And with this, okay, before last minute for questions, I want to invite you for the next 3 topics until the end of the year. Next Tuesday is going to be very challenging for me. I want to invite software engineers, and I want to talk about with them, not only with them, but mainly about what is good software engineering? What makes a good software engineer? And have we forgotten our primal engineering instincts, as I call it, meaning that we, because of all the resources we have today, and as Evelina said, if somebody doesn't like it, we will change it. This is also kind of valid for the code, the quality of the code we write. If it breaks, we'll fix it. Why think about it now? So that's the topic about how to be conscious software engineer. Then the first webinar from the series was about high quality user stories. It was a lot of talking from my side, much like today, but I want to make a workshop and I'm collecting examples. I want to really show you how from one sentence user story that we're all used to work with, we can come up with all this, we can come up with the requirements that contain everything we also talk today. What should a good looking, inspiring user story contain? How it should be written, how it should be structured, what the acceptance criteria, what the acceptance test case should look like. So I'm collecting, well, for the workshop is going to probably be 2 hours plus. We would be able to do 1 or 2, not 1, but let's say 2, 3 user stories. If you have anything in mind, share, write me, find me, you know where to find me, LinkedIn, Twitter, Facebook, wherever, Slack. Send me a user story and we can make, we can actually work with it. We can change it so that it doesn't, kind of, if there's anything sensitive, we can just rewrite it to be more generic and so forth. But yeah, if you have anything that you are willing to see live, I would be happy to. And the last for the year will be, again, something similar to today's. What is performance testing? And why we should start also early thinking about performance and non-functional testing in general, and not wait, until we're on production for 2 years and until everything collapses at a certain moment, because there is a saturation point for every new software where it works for a while and then suddenly it all goes down. So join, so subscribe or sign up on Eventbrite. And before we end, I'll send you the link to the feedback form, please. Ask for feedback, don't wait for feedback. This is one of the primal testing principles, not only testing, but yeah, high quality software principles and efficiency. And if you're not totally exhausted already, more questions. How do you feel? Any issues you have right now with testing? What about the others? Should I call you by your name? Okay, I guess I'm in the background. Thank you. Thank you so much. Thank you so much. Follow me, find me, ask me anytime. I have right now, my sole goal and purpose is to share my experience with others. So if you have any questions, I'm really open for conversation at any time. This is where you can find me. And I stop the sharing. I'll stop the recording in a second. 1, 2, 3. Thank you so much.